Hey everybody, and welcome to another deep dive.
Glad to be here.
Today we're going to be tackling a topic that's honestly become as fundamental as electricity in our modern world,
Yeah, absolutely.
and that's computer networking.
It's everywhere.
We've got a stack of AWS training docs
Oh, yeah.
that we're going to be diving into, and trust me, these aren't like your typical sleep-inducing manuals.
No,
We're going to pull out like the pure gold, the need-to-know stuff,
absolutely.
so you can walk away feeling like a networking ninja by the time we're done with this deep dive.
Yeah. And you know what's really interesting is once you understand these fundamentals, you start to see networks everywhere.
Oh, totally.
You start to see them in your home Wi-Fi. You start to see them in the massive infrastructure that powers the internet.
Yeah.
It's kind of like you get this secret decoder ring for the digital world.
Okay, so let's unpack this a little bit.
Yeah.
First things first, what even is the internet?
Right.
I mean, we use it every single day.
Every day.
But how did this, global web of connections come to be?
Right.
It's so easy to take it for granted.
For sure.
But the story of the internet is actually surprisingly fascinating.
Yeah, it is.
Would you believe it started back in the 1960s?
Yeah, you wouldn't believe it.
With the U.S. Department of Defense.
Uh-huh.
And they were experimenting with this revolutionary idea called packet switching.
Right.
Which in simple terms means breaking data down into these smaller packets
Yeah,
and sending them independently across different routes.
that's right.
Wait, hold on. Sending data in, pieces.
Yeah.
Wouldn't that make things even more complicated?
It sounds counterintuitive,
Yeah.
but actually it's the opposite. Packet switching makes data transmission so much more robust.
Really?
Yeah, because even if one route fails, those packets can just find an alternate path
Oh,
to get to their destination.
interesting.
It's kind of like having multiple backup routes on your GPS.
Okay, that's brilliant. So no more getting lost in the digital wilderness thanks to packet switching.
That's right.
But how did different computers start speaking the same language?
Yeah, that's a good question. That's where TCP/IP came in.
Okay.
In the 70s, Transmission Control Protocol Internet Protocol.
Okay.
And it basically established a common set of rules for communication across the internet.
Got it.
Without it connecting different networks would be like trying to assemble a puzzle where all the pieces are from different sets.
Okay, so TCP/IP is like the glue that holds the internet together.
The Rosetta Stone.
Wow, amazing. Okay, so I'm picturing this early internet as this exclusive club for tech wizards.
Yeah.
When did it become accessible to everyday folks?
Yeah, good question.
Like you and me.
Well, the 80s brought a screeching revolution.
Oh,
Dial-up.
dial it.
Remember those days?
Oh, yeah.
You'd be waiting impatiently for the connection to establish.
Oh, wow, yeah.
And as primitive as it seems now,
Totally.
dial-up opened the doors to email and basic web browsing for millions of people.
Oh, I remember those dial-up days.
Yeah.
The anticipation,
Yeah.
the sound of the modem connecting. It was like a ritual.
Yeah, absolutely.
And then came the 90s, and the World Wide Web just exploded on the scene.
That's right.
Right?
Yeah.
Suddenly the internet wasn't just about text anymore.
Yeah.
It was visual,
Totally.
interactive,
Uh-huh.
just full of possibility.
Yeah. It was like you said, explosion is the right word.
It really was. And then the 2000s
Right.
ushered in the era of smartphones.
Yes.
And a constant state of connectivity.
Yeah. Always on.
Right.
Yeah.
So we went from dial-up to broadband,
Uh-huh.
from clunky desktops
Yeah.
to these sleek mobile devices.
Right.
And networks had to evolve at lightning speed to keep up.
That's right. Yeah.
Wow, what a journey.
It's crazy to think about
Right.
how far we've come.
It's mind-boggling to think how far we've come in just a few decades.
Absolutely.
Okay, but let's get down to brass tacks here.
Okay.
How does computer networking actually work?
Right.
I'm talking the nitty-gritty details,
Yeah, let's
the nuts and bolts that make this whole internet thing tick.
look under the hood.
Right.
Imagine the internet like a vast highway system.
Okay.
Okay, your computer is a car,
Okay.
your message is the driver,
Got it.
and a website, say Amazon, is your destination.
Uh-huh.
The roads connecting everything are the networks,
Okay.
with data packets zipping along like tiny, super fast vehicles.
Okay, I'm picturing data packets racing down the information superhighway.
That's right.
But what about all these different parts of a network that I keep hearing about?
Yeah.
Nodes, hosts,
Yeah.
switches, routers.
Yeah.
It sounds like a digital traffic jam.
Don't worry, it's actually quite organized.
Okay.
Think of it this way. A node is any device.
Uh-huh.
connected to a network.
Okay.
It could be your computer,
Okay.
a server, a printer, even your smart refrigerator. Wow. Okay.
A host is a specific type of node that offers services,
Okay.
like a web server hosting a website.
Got it.
Okay.
So a host is like a rest stop
Exactly.
on our data highway,
Yeah.
providing specific services to travelers.
Yeah.
But what about those switches and routers I keep hearing about?
Right. Imagine a basic network.
Okay.
Your computer connects to a switch,
Uh-huh.
which then connects to a router.
Okay.
The switch is like a local traffic cop,
Got it.
directing data packets within your home or office network,
Oh.
ensuring they reach the right device.
Okay.
The router, on the other hand, is like a border crossing,
Okay.
connecting your network to the wider internet.
Okay, so the router is our gateway to the vast world of the internet.
Exactly.
Okay, but what about data itself?
Right.
What is it really? I mean,
Yeah.
I know it's what makes the internet go round,
Uh-huh.
but it's such an abstract concept.
It is a little bit, yeah. At its core, data is just a bunch of zeros and ones.
Okay. It's binary code that computers can understand,
Okay.
but those zeros and ones can represent anything.
Okay.
Text numbers, images,
Yeah.
videos, music, you name it.
It's like a secret code
Yeah,
that unlocks all the wonders of the digital world.
that's a good way to put it.
But how do computers make sense of this code?
Yeah,
Like, how do they know what to do with it?
that's where the OSI model comes in.
Okay.
Right? It's a framework that helps us understand how data travels across a network.
Okay.
There are 7 layers, but for now, let's focus on layers 2 and 3.
Okay.
The data link layer and the network layer.
Okay. Layer 2 data link. What happens there?
Okay.
Is it like a digital customs checkpoint or something?
You could say that at layer 2, we're adding a shipping label
Okay.
to our data packets
Got it.
with something called a MASI address.
The mesh address.
Yeah, and it's a unique hardware identifier
Okay.
for each device's network interface card, like a digital fingerprint.
Wow. Fascinating.
Yeah.
Okay. So layer 2 is all about making sure our data packets have the correct from address.
That's right.
What about layer 3, the network layer?
Okay, so at layer 3, we're giving our data packets their destination address,
Okay.
which is the IP address.
Got it.
And this is what routers use to determine the best route
Uh-huh.
for the data to travel across the internet.
So layer 2 is like labeling the package.
Exactly.
Layer 3 is like writing the address on the envelope.
Yes.
It's all starting to click. Okay, but what about the physical stuff?
Okay.
The actual tools and components
Yeah.
that make up a network.
Yeah.
I'm picturing like a tangled mess of wires and blinking lights.
It can seem that way, but trust me, there's a method to the madness.
Okay.
Okay, first we have clients, which are devices like your computer
Uh-huh.
or your smartphone
Okay.
that request information from servers.
Okay, like when I'm browsing Amazon and adding things to my cart,
Exactly.
my computer is the client.
Yes.
Making those requests to Amazon servers.
Precisely.
Okay.
And servers are powerful computers that respond to those requests.
Okay.
In your Amazon example, the server processes your order, checks inventory, and sends you a confirmation.
It's like a digital waiter,
Yeah,
taking our order and bringing us our digital food.
that's a great way to think about it.
But how does my computer physically connect to the network?
Yeah,
Is it through those network cables I was imagining?
you got it.
Yeah,
Okay,
got
okay.
it.
So your computer connects to the network through a network interface card, or NIC.
An NIC.
NIC, and that acts as the physical gateway.
Got it.
And each NIC has that unique MC address we talked about earlier, making it identifiable on the network.
So the NIC is like the doorway between my computer and the network.
Exactly.
And what about those cables?
Right.
Are they all created equal?
That's a good question. Actually, there are different types, each with its own strengths and weaknesses.
Oh.
Fiber optic cables are the Ferraris of the data world. Okay, they use light to transmit data at blazing speeds.
Got it.
Coaxial cables, commonly used for cable TV, are like reliable sedans.
Okay.
While twisted pair cables, your standard Ethernet cables, are the workhorses of the network.
Okay.
They're connecting most devices in homes and offices.
So we've got clients,
Yes.
servers, NICs, cables. Anything else I should know about?
You can't forget about those traffic directors.
Okay.
We talked about earlier switches and routers.
Right.
Switches manage data flow within a local network.
Uh-huh.
using those MAC addresses to ensure data packets get to the right device.
Okay.
Routers connect multiple networks together,
Oh.
like your home network to the internet,
Uh-huh.
using IP addresses to route traffic intelligently.
It's amazing how all these components work together.
It is.
Like a perfectly synchronized orchestra.
It really is like a symphony.
It really is.
Yeah.
Okay, but we've only talked about one type of network so far.
Right.
What about those LANs and WANs I keep hearing about?
Yeah. Good point. You're right. There's a whole world of networks out there.
Okay.
Okay, so a LAN, or local area network,
Okay.
is like your home or office network.
Okay.
It connects devices within a limited area, usually using Ethernet cables or Wi-Fi.
So my home Wi-Fi setup is a LAN.
Exactly.
Right.
A WAN or wide area network.
Okay.
On the other hand, spans a much larger geographical area connecting multiple LANs together.
Okay.
The internet itself is the biggest WAN of them all.
Whoa.
Yeah.
Okay, so my little home LAN is just a tiny part of this massive global network.
It's all about scale
Okay.
and the technologies used to connect everything.
Okay.
But we'll dive deeper into that in the next part of our deep dive.
Okay.
The fascinating world of WANs and internet infrastructure.
Okay. I can't wait, but before we move on,
Yeah.
let's talk about network topologies.
Okay.
What exactly does that mean?
Right.
Is it like a map of the network?
That's a great way to think about it. Okay. A network topology describes the arrangement of devices and connections within a network.
Okay.
Okay, and it can be physical, showing the actual layout of cables and devices,
Okay.
or logical, representing how data flows through the network,
Got it.
regardless of the physical setup.
So it's like having both a street map
Exactly.
and a traffic flow diagram for our network.
Exactly.
Right.
There are several types of physical topologies.
Okay.
Okay, in a bus topology, all devices are connected along a single cable,
Okay.
like a string of pearls.
Okay. That seems simple, but what happens if the cable breaks?
Yeah,
Doesn't everything just grind to a halt?
that's right. That's one of the vulnerabilities
Okay.
of the bus topology.
Okay.
Okay, a more common topology is the star topology,
Mm-hmm.
where all devices are connected to a central hub, typically a switch.
And that's why we see so many network switches.
Exactly.
Okay, what about other topologies?
There's the mesh topology,
Okay.
where every device is connected to every other device.
Oh, wow.
Okay, creating multiple paths for data.
Okay.
It's super resilient,
Uh-huh.
but can be complex to manage.
Okay.
And finally, there are hybrid topologies, which combine elements of different topologies to create customized solutions.
So it's like mixing and matching.
Exactly.
Different network designs to create like the perfect fit for a specific need.
Right.
Clever. Okay, but what about those virtual private clouds I keep hearing about?
Yeah.
Do they have their own topologies?
Absolutely. Amazon's Virtual Private Cloud, or VPC,
Okay.
is a great example of a logical topology.
Okay.
Okay, it's like creating your own private network
Right.
within the AWS cloud,
Got it.
giving you complete control over your network structure and security.
Okay, so topologies are all about how the network is organized both physically and logically.
That's right.
Got it. Okay, but before we wrap up this part of our deep dive,
Yeah.
let's talk about network management models. I've heard of client-server and peer-to-peer,
Yeah.
but what's the difference?
Right.
And why should I care?
Good questions. Network management models define how devices interact and share resources.
Okay.
In a client-server model, you have centralized servers that provide services to clients, like your computer accessing a website.
Okay, so it's like a traditional restaurant where the kitchen, the server, prepares food data for customers' clients upon request.
A perfect analogy.
Okay.
Yeah, the client-server model is efficient and easy to manage,
Uh-huh.
but the server can become a single point of failure
Oh,
if it goes down.
that doesn't sound good. Is there an alternative?
That's where peer-to-peer networks come in.
Okay.
In a peer-to-peer network, all devices have equal status
Okay.
and can share resources directly with each other without relying on a central server.
So it's more like a potluck dinner
Exactly.
where everyone contributes and shares their dishes directly.
That's right.
Okay.
Yeah, peer-to-peer networks are more resilient and can be faster for certain tasks,
Okay.
but they can also be more challenging to manage and secure.
This is all so fascinating.
It is.
We've covered so much ground already,
I know, right?
from the history of the internet to the different components,
Yeah,
types and topologies of networks.
absolutely.
And we've only just scratched the surface.
We have.
Welcome back.
Glad to be back.
Last time we explored the evolution of the internet
Yeah,
and kind of got a glimpse of the intricate machinery that makes it all work.
we did. We covered a lot.
Yeah, we really do.
From the basic components of a network to different types of networks and topologies.
Right.
But now it's time to dive even deeper and understand how data actually travels across those networks.
Okay. I'm ready to hit the information superhighway again.
Let's do it.
But before we do,
Yeah.
can we talk about those network protocols?
Okay.
It sounds so technical.
Yeah.
I'm not sure I fully grasp, like, what they are.
Right.
Or why they're so important.
Think of network protocols like the traffic rules of the internet.
Okay.
There's a set of standardized rules and procedures that govern how data is formatted, transmitted, and received between devices on a network.
Okay, got it.
Without them, data transmission would just be chaotic and unreliable.
So protocols are like the traffic signals and the road signs.
Exactly.
That keep those data packets moving in an orderly fashion.
Yeah, that's a good way to think about it.
But there must be tons of different protocols, right?
There are.
Like, how do we even begin to understand all of them?
Yeah, so there are many protocols, each designed for specific purposes. But let's focus on two of the most fundamental ones. TCP and UDP.
TCP, UDP.
Okay, TCP stands for Transmission Control Protocol.
And
it's all about reliability. It ensures that data is delivered in the correct order. Without any errors or missing pieces.
That sounds crucial.
Yeah.
Especially if we're talking about, like, sensitive data.
Yeah, absolutely.
Like financial transactions or confidential emails.
Right.
But how does TCP achieve this level of reliability?
So TCP establishes a connection between the sender and the receiver before transmitting data. Like a phone call.
Got it.
Okay. It uses a three-way handshake process.
A three-way handshake.
Yes, to make sure both sides are ready to communicate.
Interesting.
Okay, then it breaks the data down into packets, numbers them, and sends them one by one. The receiver acknowledges each packet as it arrives, ensuring that everything is received in the right order and without any errors.
So it's like a super organized delivery service with confirmations at every step.
Exactly.
But doesn't all this back and forth communication slow things down?
You're right. TCP's reliability comes at the cost of speed. It's a bit slower than other protocols because of all the error checking and retransmission that might be needed.
That makes sense. Okay, so when speed is more important than, like, guaranteed delivery, what do we use?
That's where UDP comes in.
UDP.
User Datagram Protocol. Think of UDP as sending a postcard.
Postcard?
You write the address, slap on a stamp, and send it off. Hoping it reaches its destination.
Got it.
There's no guarantee of delivery, and you don't get a confirmation when it arrives.
So it's a bit more of a fire and forget approach.
Exactly.
Okay, when would we use UDP instead of TCP?
UDP is ideal for applications where speed is paramount. And occasional data loss is acceptable.
Got it.
Like video streaming or online gaming. A few dropped packets here and there won't ruin your gaming experience or make your movie unwatchable.
That explains why my video sometimes buffers.
Exactly.
It's those UDP packets getting lost in the digital ether.
That's a good way to think about it.
Okay, I'm starting to see how these protocols work.
Good.
But what about IP addresses? I know they're unique identifiers for devices on a network.
Right.
But how do they actually work?
Imagine an IP address as your device's unique digital address. Like a street address in the physical world. Just like a postal worker uses your address to deliver mail.
Right.
Routers use IP addresses to route data packets across the internet. Ensuring they reach the correct destination.
So when I type in a website address into my browser, it gets translated into an IP address.
Yes.
And that's how my computer knows where to send the request.
Exactly. There's a system called DNS. Or domain name system. That acts like a giant phone book for the internet. Translating those human-readable website names into the numerical IP addresses that computers understand.
Wow, that's brilliant.
Yeah.
Okay, but I've heard there are different versions of IP addresses.
Yes.
Like IPv4 and IPv6.
That's right.
What's the difference? And why do we need a new version?
So IPv4 is the original addressing system. And it uses 32-bit addresses. That allows for about 4.3 billion unique addresses.
4.3 billion? That's a huge number.
It is.
Why do we need more than that?
Well, with the explosion of the internet and the proliferation of internet-connected devices.
Right, like everything's getting connected these days.
We're running out of IPv4 addresses.
Really?
Everything from smartphones and laptops to smart refrigerators and even cars needs an IP address to connect to the internet.
Wow, I had no idea we were running out of digital addresses.
We are.
So what's the solution?
IPv6 to the rescue.
IPv6?
Yes, it's the next generation of internet addressing.
Okay.
And it uses 128-bit addresses.
128-bit, okay.
That provides a mind-boggling number of unique addresses.
Okay.
Enough for every device on the planet and then some.
Okay. That's a number I can't even comprehend.
It's a lot.
Yeah.
It's a big number.
So IPv6 is the future of internet addressing.
Absolutely.
Okay, good to know.
Yeah, it's being adopted more and more every day, offering not only a vast address space, but also improved security and efficiency.
That's good to know.
Okay.
But before we get too futuristic here, let's talk about subnetting. I know it has something to do with dividing networks.
Yes.
But I'm not sure why we'd want to do that.
Think of subnetting, like dividing a large city into smaller neighborhoods.
Okay.
Okay, it's a way to break down a network into smaller, more manageable subnetworks or subnets.
So creating mini networks within a larger network.
Exactly.
But why is that beneficial?
Okay.
Wouldn't it be easier to just have one big network?
You would think so, but subnetting actually makes network management much more efficient.
Really?
It improves performance by reducing network congestion.
So it's like creating separate lanes on our data highway.
Exactly.
To prevent traffic jams.
Yes.
Got it.
Subnetting also enhances security.
Okay.
By isolating different parts of a network, making it harder for unauthorized users to access sensitive information.
Right.
And it simplifies IP address management.
Okay.
Allowing organizations to make the most of their limited address space.
I'm starting to see the value of subnetting. But how do we actually create these subnets?
We use something called a subnet mask.
A subnet mask.
Which is a bit like a stencil that divides an IP address into two parts.
Okay.
The network portion and the host portion.
Okay.
By manipulating the subnet mask network, administrators can create subnets of different sizes, tailoring the network structure to their specific needs.
So the subnet mask acts like a digital boundary.
Yes.
Separating those neighborhoods within our network.
A good way to think about it.
Okay. It's all starting to come together.
Good.
I have to admit, my brain is feeling a little overloaded.
I understand.
Can we recap what we've covered?
Of course.
Before we move on.
Absolutely. So we've learned about the essential role of network protocols, like TCP and UDP, which govern how data flows across networks, ensuring reliability or prioritizing speed depending on the application.
We also explored IP addresses.
Yes.
Those unique digital addresses for every device on the internet.
That's right.
And how the new IPv6 system is solving the problem.
Yes.
Of dwindling IPv4 addresses.
Exactly.
And we delved into the world of subnetting.
We did.
Discovering how dividing networks into smaller subnets can improve performance, security, and IP address management.
That's right. We covered a lot of ground.
This has been an incredible journey so far.
It has.
And I'm eager to see what other wonders await us on the information superhighway.
Well, get ready, because in the next part of our deep dive, we'll be exploring the fascinating world of the Internet of Things.
Okay.
And the challenges and opportunities of enterprise mobility.
Welcome back to the final leg of our networking deep dive.
We've come a long way.
We have.
From those early days of packet switching to the complexities of subnetting.
Yeah. It's been quite a journey.
It has.
But now we're stepping into a world where, like, billions of devices are talking to each other.
Yeah, the future is here.
It is.
It's happening now.
Creating this, like, truly interconnected digital landscape. The Internet of Things.
The Internet of Things.
IoT for short.
That's right.
I have to admit that term still sounds a bit futuristic to me.
It does have a bit of a ring to it, doesn't it?
Yeah.
It might sound like something out of a sci-fi movie.
Yeah.
But IoT is very much a reality today.
Okay.
It's the concept of connecting everyday objects to the internet, allowing them to collect and exchange data. And even interact with each other.
So we're talking about like smart refrigerators that order groceries when you're running low.
That's right.
Or thermostats that adjust the temperature based on your preferences.
Yeah, exactly. Or your smartwatch that tracks your fitness.
Right.
Your car that gives you real-time traffic updates.
Right.
I mean, it's all around us already.
It sounds incredibly convenient.
Yeah.
But also a little creepy.
Yeah, I mean, it's definitely a paradigm shift.
Yeah, it is.
You know, we're moving into a world where everything is connected.
Right. And it's not just like consumer gadgets.
That's right.
Right.
Yeah.
Like IoT is revolutionizing industries.
Yeah, absolutely.
Like healthcare, manufacturing, transportation.
Think about it like in healthcare.
Yeah.
You could have remote patient monitoring. Wearable devices that track vital signs and transmit that data to doctors.
Okay.
In manufacturing, you could have sensors on equipment
Okay.
that monitor performance and predict maintenance needs.
Got it.
Reducing downtime and increasing efficiency.
Wow. So it's like a whole new level of automation and data collection.
It really is.
It is.
It's changing everything.
Yeah, it is.
Yeah.
Okay, I'm starting to see the potential.
Good.
But how do all these devices actually communicate?
Right.
Do they have like tiny little keyboards and screens?
Not quite.
Okay.
So IoT devices use a variety of wireless technologies,
Okay.
like Wi-Fi, Bluetooth, cellular networks to connect to the internet.
Okay.
And they often rely on specialized protocols like MQTT.
MQTT.
Which is designed for efficient data transmission with minimal power consumption, perfect for those battery-powered devices.
So it's like a secret language specifically for these connected gadgets.
You could say that.
It all sounds very impressive.
It is.
But I can't help but think about security.
Right.
Isn't it risky to have so many devices connected to the internet?
Yeah. It's a valid concern.
It seems like a hacker's dream come true.
With more devices connected, the potential attack surface grows exponentially.
Right.
So security is absolutely paramount in the IoT world.
Okay.
That's why it's crucial to implement robust security measures.
Okay.
Like strong authentication encryption, regular software updates to protect those devices from cyber threats.
So securing our smart toasters is just as important as securing our computers.
It is all part of the same interconnected ecosystem.
It's a lot to think about.
Yeah, it's a big challenge.
But how does AWS fit into this IoT landscape?
Right.
What role do they play?
So AWS offers this powerful platform called AWS IoT Core, specifically designed to manage and connect billions of IoT devices. It provides secure communication channels, data storage and processing capabilities, and even machine learning tools to analyze the vast amount of data generated by these devices.
Wow. So AWS is like the central nervous system for the Internet of Things.
Yeah, that's a great analogy.
Like connecting and managing all these devices.
Bringing order to the chaos.
Yeah.
Yeah.
It's mind-boggling.
It is. It's a rapidly evolving space.
Let's shift gears a bit.
Okay.
And talk about enterprise mobility.
Right.
I know it refers to using mobile devices for work.
Yep. Smartphones, tablets, laptops, all that.
But what are the real benefits and challenges in this space?
Well, enterprise mobility is transforming the modern workplace, giving employees the flexibility to work from anywhere, anytime.
Right.
But as you can imagine, this newfound freedom also introduces new challenges.
Yeah.
Particularly when it comes to security and data management.
It makes sense. Companies need to ensure that sensitive information is protected.
Absolutely.
Even when accessed from personal devices.
Right.
Outside the traditional office environment.
Yeah, it's a big concern.
What are some best practices for addressing these concerns?
Mobile device management or MDM solutions.
MDM.
Yeah, MDM solutions are crucial for securing and managing the mobile workforce.
Okay.
These solutions allow companies to enforce security policies, remotely wipe data if a device is lost or stolen, and even control which apps employees can install.
So it's like having a virtual IT department.
Got it.
That can keep tabs on all those mobile devices out in the wild.
That's a good way to think about it.
Pretty impressive.
It is.
But before we wrap up our deep dive, is there anything else our listeners should know about?
Sure.
How AWS is supporting this mobile revolution?
Absolutely. One of the most innovative solutions is Amazon Workspaces.
Okay, Amazon Workspace.
Which provides virtual cloud-based desktops. Accessible from any device.
Got it.
It's like having your entire work environment. Applications, files, and settings available at your fingertips no matter where you are.
So it's like carrying your office in your pocket.
That's a good way to put it.
That's incredible.
It is. It's very powerful technology.
I'm amazed at how much ground we've covered.
Me too.
In this deep dive.
Yeah.
We've gone from the humble beginnings of the internet to the mind-blowing possibilities of the Internet of Things.
It's been quite a ride.
It has, and the mobile workforce.
Yeah.
We've explored the intricate workings of networks, the critical role of protocols and IP addresses, and the innovative solutions that are shaping the future of connectivity.
We've really gone from A to Z.
We have.
Haven't we?
You now have a solid foundation.
You do.
In networking fundamentals and hopefully a newfound appreciation for the complex but elegant systems that connect us all.
Absolutely.
But remember, the world of technology is constantly evolving.
Always changing.
So never stop learning, exploring, questioning.
Keep that curiosity alive.
Who knows what incredible innovations lie just around the corner?
That's right. The future is full of possibilities.
Well, thanks for joining us on this exhilarating deep dive into computer networking.
It's been a pleasure.
We hope you've enjoyed the journey as much as we have.
I certainly have.
Until next time, keep those connections strong and stay curious.
Stay curious.